Real world data, when graphed, rarely falls on that exact line that we've been working with up until now. Data is classified as linear if the points approximate to a line on a graph. So in this case, there are techniques that we use to approximate these equations, and we call them the lines of best fit. Graphing calculators can give us that line, and it can also tell us the accuracy of that line of the actual data that we're inputting. But again, this line that we've been grafting is an exact solutions, where this data that we're going to go with when we start talking about scatter plots is going to be generally a linear information, but not exactly a line. So as we look at this, we're going to see some trends when we're talking about scatter plots. And here are some examples of scatter plots. And what you'll see here is, as we start from the center and move outward, let's see here, we can look at, let's start from the outside and move in, and we look at this far right graph, and it looks to be generally a positive slope. Now, on the other hand, if we go far left, we have what would be considered a negative slope. And when we get into the middle right here, this one right here in the middle, you really can't tell if we have a upward trend, a downward trend, or any trend at all. So this is considered no relation, because I can't tell what the data is doing here. Where if, as I move out to the right, I can sort of start to see that I have a general upward trend. It's loose data, and then as we get closer or farther out to that exact point, we start to see how our information is grouping around that line. And the same thing goes as we move left of, we have what seems to be a general negative trend, and then a tighter negative trend. And these, work in percentages, and, this is a 100% straight line, positive, and this one over here is 100% straight line, and it has a negative slope. This one has a negative correlation, is what we're talking about here with scatter plots, a positive correlation. And then no here, correlation in the middle. And then varying degrees of strength in a positive relationship, varying degrees of strength as a negative correlationship. So those are what we're looking at here, and we will graph some stuff. And until we learn how to do the R factor on the calculator, we're just looking at generally a positive and a negative, or a no correlation. So let's see here. Moving forward, it says make a scatter plot describing its correlation and making a scatter plot and describing its correlation. Well, make a scatter plot of the data on the table with what relationship goes with the scatter plot shown. So if we do that, let's see, we know we're going to need to create a graph. And it looks like my X data would be dollars spent, my Y would be the gallons bought. So here's my dollars, here's my gallon. My gallons, dollars spent go from 4 to, looks like 13. Let's see here, 2, 4, 6, 8, 10, 12, 14. That covers that. And then our gallons look like they go as low as 1 gallon up to 3.3 gallons. So we can go ahead and say 1 gallon, 2 gallons, and 3 gallons. In graphing these points, okay, my intervals are consistent. And as we go from $10 is 2.5 gallons, so it puts me right there. 11 is 2.8, something about right there. 9 is 2.3, right about there. 10 is 2.6. 13 is 3.3. 5 is 1.3. 15 is 1 point, I'm sorry, 8 is 2.2. And 4 is 1.1. Okay, so if we look at this data, it does not form necessarily a straight line. But if I were to estimate with a line, I could say, well, splitting my data. You know, some data falls on the line, some data doesn't fall on the line, but I can look at that line and that data and say, generally, it has a positive, I was about to spell that wrong, a positive correlation. You know, if you look back and you sort of squint and you look at how the data's moving, sort of looks like it's moving in a positive direction as I look at the information from the bottom left to the top right. And now it says consider, I don't have to do anything more of this, but so the gallons of gas, depending on the amount of money spent, would determine how many gallons of gas I have. Now, and gasoline does fluctuate on a day-to-day basis, so we wouldn't expect that to be a 100% linear equation. Now consider the population of a city and the number of letters in the name of the city, and would you expect it to have a positive relationship, a negative relationship, or no relationship? And I would say that the number of letters in a city and the population are pretty much not related. So I'd say there's no connection right there. So no correlation. And that's part of looking at the relationship and the causation of your data. Writing an equation of a trend line now, and make a scatter plot of the data. All right, and then we're going to draw a trend line and write its equation. So let's see, let's start with our trend, our data. All right, so I have my body length is my dependent information, and my age is going to be the independent information. So as I go to graph this, I'm going to graph age 1 in months is going to be 8 body length. 2 is going to be 11.75. Again, I'm estimating. 3 is 15.5. 4 is 16.7. 5 is 20.01. 6 is going to be 22. 8 is going to be 26. And number 9, in 9 months, you're going to be 29. So now we don't have an exact relationship here. So we do have a scatter plot. And it says, draw a trend line and write the equation. Well, if I draw a trend line here, what you end up having is the data. As I draw my trend line, I want to sort of split my information. Right, straight lines sort of going through my data. And this thing right here we know should be my y-intercept. So it looks like I intercept somewhere around the points of maybe 7. So my y-intercept is going to be about 7 body length. And then I'm going to have a slope here that is going to determine, and I could pick 2 points. You know, I could pick that point right there, and I could pick this point right here. Those are about splitting my information. So if I took that point and this point, and I did my slope-intercept form, I would have my slope is equal to 26.5 minus 11.75 over 8 minus 2. Let me see here. All right, so as I'm calculating my slope here, I get something along the lines of 14.75 over 6, which equals about 2.46. So the slope I came up with was about 2.46. So my equation would be, in this case, I guess y equals 2.46x plus 7. And that is going to give me a general equation for my trend line that I created. Now, we have ways to put this into the calculator and it will give us the exact information, but right now we are doing an approximation. So if I look, and it's asking me to approximate now, what is the approximate body length of a 7-month-old panda? Well, when I go and look at 7 months old, I have that point right there, which is about 23. About 23. That's if I wanted to guess just by looking at my graph, that's possibly where 7 months puts me. But if I go ahead and do some, inputting, if I put 7 months into my equation, I end up getting 24.22. So I could estimate somewhere around 23, 24 just based on my line. But of course, if I were to throw it into the equation that I just came up with, it told me that it would be 24.22 inches. And that's coming up with the equation of line based on my data using the slope and different things that we've been using in class. Now, finding the line of best fit using a calculator, well, you can use a graphing calculator to find the equation. Line of best fit to the data to the right, and what is the correlation coefficient to 3 decimal places, and predict the cost of attending. So we're going to predict somewhere down here, 2012, 2013, what is my value going to be? And it's got some information in here, but on how to install it, you go ahead and hit edit on your graphing calculator, and then that brings up your, stat, which brings up your statistics data information. And you can go ahead and select edit. You can type your values in, and it's going to look something like this. Okay, so I've gone and placed my information in there, and it does say let L1 years, enter your years into L1, and then it says let X be 2000, represent the academic year of 2000, 2001, and then let X equals 2001 to represent 2001, 2002. Now, I did mine a little bit wrong, so let me go back and fix that. Because as you can see here, it looks like 2000 I input as I input 2001 as what they would have said 2000. So let me fix that the way it has it worded. So as you can see here, I've gone and input the information a little bit differently. Did it accurately according to their description. Let 2000. This one should be represented by 2000 right here. That's 2000. So this data was input incorrectly. I've gone and corrected it and enter the cost into L2, and I've put those costs into L2. And now it says to go ahead and choose stat line reg from your calculator. Let's see here. So if I went to hit stat, then it says choose line reg AX plus B. Okay, I see it, AX plus B. It looks like it's option number 4. And select enter, and then you're going to go down and select calculate. And it's going to give you your equation off the bat. So as I input the information in and I go ahead and follow these directions right here, I'm given to this form right here, which is going to be my slope-intercept form. So I have y equals a, which is 409.43 x plus b, which is negative, so which would be minus 815,446.71. So there is my equation for a line, and then it says press enter to find the equation of a line, and then also the line of best fit and the correlation coefficient. Well, depending on your calculator, what you're going to have to do is you are going to have to go to tests. So the same thing, stat, and arrow over to tests, and then you're going to have to arrow down to option F, and it is going to give you the ability to see your correlation coefficient, which is known as the variable R. So I will show you a picture here. And what we see here when we look at our calculator screen is, here's my, the R value here down at the bottom is my correlation coefficient, and that is telling me that my data is 0.9959 or 0.996 accurate. So that is how accurate the data is, the correlation. How well does the data model, how well is the data modeled by the equation of the line? So that is pretty accurate. That's not a exact one-to-one equation, but it is very good data. And then it says, predict the cost of attending in 2016 academic year. Well, according to our instructions, the 2017 year should be listed as 2016. And we never predicted 2012 over there, but that's okay. We have y equals 409.43. Going to replace x with 2016 minus 815,446.71. Going to put that in the calculator and hit enter, and it's going to give me some number. So there you go. That's using your calculator and your graphing options to come up with lines of best fit and to identify how accurate they are with their correlation coefficient, which is represented by R.